we did L3 VPN over MPLS. We are going to do L2 VPN over MPLS now. What is the difference? L3, you know that there is a routing involved. L2 is opposite. It is the opposite. L3 VPN, you remember, we created routing instance. How do you call routing instance in Cisco? In Juniper, we call routing instance. In Cisco, how do you call routing instance? The routing instance is nothing but VRF. VRF is what we call it as routing instance. So when you create VRF, what gets created? A separate routing instance, a separate routing table, a separate control plane gets created. VRF. In Cisco, we call it as VRF. Yeah. So, routing instance, VRF. You don't need those things in layer 2 VPN because it is layer 2. You don't need VRF. See, for each customer, we had routing table. And the routing was happening there in the PE router. Yeah. In the PE router, routing was happening. Now, that routing is no more needed if the customer in different site in same network. For example, here I have 10.0.0.1. This is customer edge 1 in London. போனாதான் தெரியும் அங்கே எவ்வளோ சாவர மாதிரி குளிரும் கோழி கூடு மாதிரி வீடும் லண்டன் ஓடுறவங்களுக்கெல்லாம் பைத்தியம் போயிடாதீங்க ஏதோ ஒன்று லண்டனை பெரிய ஆள் நினச்சிப்போம் நம்ம நாட்டில் லண்டன் CE2 இந்தியா கொட்டாம்பட்டி 10.0.0.2. You see, between Paris and Kottambatti, I want a tunnel. Even though this is a big internet cloud, I don't want routing because this sites are in same subnet. They are not in different network, you see. Same subnet. That's not the case in our previous topic. Here the same subnet. Kottambatti and Paris. Same subnet. So what you need is a tunnel that will move the packet simply using layer 2 information. You see, this is what it means when we say layer 2 VPN. In the internet cloud, there are hundreds of networks. On top of that, only you have this tunnel. This tunnel is on top of a big network where hundreds of networks, routers, firewalls, hiding all those routing device, you need a switch kind of, you need a wire kind of environment. You want a wire. See, when you finish L2 VPN, how it will look? It will look like this. CE1, CE2 connected using a wire. This wire is what that L2 VPN. As if you have a wire with 10.0.0.1, 10.0.0.2. The internet is now mimicking like a wire, acting as a wire. The entire internet is acting as a wire. This is what we call it as L2 VPN. See, we have a PE router here. PE1 and PE2. You see the tunnel where it starts. It is facing the customer. Whatever comes from the customer goes through the tunnel, cross the router and leaves the tunnel. In layer 3 VPN, that is not the case. Tunnel was here, isn't it? Remember BGP, MPBGP VPN. Tunnel was behind PE1, but here in front of PE1. It is facing the customer. The tunnel opening is facing the customer. Whereas here, you do routing, then only you get into the tunnel. In layer 3 VPN, routing and then getting into the tunnel. That is layer 3 VPN. Layer 2, just traffic enters and pass through. I hope you understood what layer 2 VPN means. Traffic comes, gets inside this virtual circuit. I'll give a number, virtual circuit 1. And I'll give the same number here, virtual circuit 1. Now let's say the router ID of this router is 3.3.3.3. Router ID of this is 1.1.1.1. You know what really happens? This is what happens. The original source IP address is 10.0.0.1 and the destination IP address is 10.0.0.2. Now when it enters here, what happens? 1.1.1.1 and 3.3.3.3 becomes the source and the destination. See, this is original source and destination. This is another layer 3 info getting encapsulated. Now, to reach 3.3.3.3, there's going to be a label. Using that label, it goes to 3333. So what happens is, there is an additional layer 3 header, and for reaching this destination, a label, let's say label number 40. Using that label, the traffic goes from one hop to the another, swapping happens, popping happens, and then delivered. And now the original destination will be revealed. So this is gone. The original destination is revealed and traffic is delivered. So a virtual circuit means VPN. VPN means encapsulation. The virtual circuit we manually create. If you will have MPLS between the PE routers and a routing protocol, you can negotiate this virtual circuit, and then all the customer traffic can use it to go from London, Paris to Kotambati, India. I'm going to quickly do this lab. It's a very simple lab. And this is point-to-point layer 2 VPN. In our next class, we'll be doing multi-point. We call it as VPLS. This is point-to-point. This is also L2 VPN. Because it's a layer 2 VPN, you see there's no need for IP address on the customer facing interface F01. There is no need for an IP address. We want a layer 2 circuit to ping from customer edge to the remote customer edge. Right, so let me bring the provider first and then we'll talk about the customer side. Bringing provider is nothing but assigning IP address and then the routing protocol followed by MPLS. I'm going to do in one stretch. Take the notepad, take a fresh page. Okay, I can use the same. This is for router P1, so I say P1 is 11.11.11.11. You need to know this loopback because this is what I'm going to use to negotiate layer 2 VPN tunnel. And then F00 is 10.12.0.1 or 11. The mask is 16. I do not want to have any study route. IP route OSPF 1 area 0. And likewise here also I say IP route OSPF 1 area 0. And also MPLS. I would like to enable MPLS. That's all. This is what I need on PE1. Something is wrong with my notepad configuration. Not IP route, IP OSPF. Because when we work with multiple vendors, this type of problem will come. Juniper is IP route. Okay, now we will finish PE2, then we will come back to the other routers. PE2 is 22. And here it's 1032.22. Put it on PE2. Done. What is next? Let's finish P2. Or let us do P3. 3333, and then F01 is 323, F00 is F00 is 23. This will go to P3.
Sir, actually, I'm Tapa Palirking, sir. F0023.
F00 is 23, correct. F00 is 23. F01 is 32, huh? Oh, yes. So, these two commands will erase the previous wrong configurations. Okay, now P2 is 2222, and then F01 is 23 2, and F00 is 12 2. P2. Okay, I'm expecting a reachability between P1 and P2 now. So ping 22, 22, 22, 22 with the source 11. If this ping happens, then we are ready to go. Let me also check the trace with the source so that MPLS status also can be known. Looks good. Okay, now where we are. We are going to customer side. Now, interface F00 192.168.0.1, and on CE2 Okay, this is done between C1 and C2. If you need reachability, you need what? VPN. See, show IP route. You don't have any route for ISP. You don't have any route, no static route, nothing point towards ISP because we no need. This is not a layer 3 routing. The middle one is like a switch. Do we have a gateway for a switch? No. So if the tunnel is ready, this ping will happen. This ping will happen if the tunnel is ready. The tunnel is not yet created. Now going to PE1 to create the tunnel, as I said, you need to know the loopback interface address of PE2, and we already know it is 22. Now go to the customer facing interface F0/1, and then no shut. As I said, there is no IP address. You need to say this X connect. What is the peer address? Means the PE2 address. Now you need to give any number, but that number should be same when you configure on PE2. That's it. All right, that's all. Likewise, I'll go to, before I go to PE2, I want to show you. Show X connect virtual circuit X connect peer 22, 22, 22, 22. You may have multiple virtual sessions with this 22, 22, 22. So you have to say which virtual circuit ID. 1. Detail. It says it is down. On the second segment side, the other side. On the PE2 side, it is not up, it is down. But to go to 22, it has got a label. It is ready this side. Segment 1 side, it is ready. Segment 2 side, it is not ready. Yeah. So it is down. X connect is down. Okay. We know the reason. PE2 is not yet configured. Let's go to PE2. No shit. X connect. What is the peer address? Virtual circuit ID must be same. Encapsulation using MPLS. Now see, the virtual circuit has come up. See, LDP neighbor has come up, which means there is a wire. There is a virtual wire through which the labels are distributing. Label LDP, I can see neighbor with PE1. Now I'll take you back to PE1 and show you. You see, this time it is up. Okay, using MPLS. Now going to the customer side, the magic happens now. You see, the ping is going. None of this router in the core knows 192. Do any of the ISP router knows 192? See? No, they don't know. And the customer's route or not advertised to PE. See, that's the biggest difference. In the layer 3 VPN, customer routes are advertised to provider edge. In layer 2 VPN, no, we don't do that. No route is advertised. Now let us go and sniff the packet and see how the packet looks. See, I'm going to sniff packet in between P2 and P3, and I'm going to ping now. You see, when I ping, what happens? This is that ping packet. I'll open one of it. Look at this. Look at this. This is what I was talking to you. This is the original source and destination. But this is the layer 2 VPN source and destination. 17. 17 is to identify 11.11.11.11. See, the source is going from P2 to P1. Sorry, CE2 to CE1. So, according to what I am seeing here, I should see 17 in P2 router for 11.11.11.11. Let us check that. Show MPLS forwarding 17. The local label 17. Is that 17? I saw that. Yes. The local label 17 is what? Okay, then the very next router, not this router. The very next router. What is the very next router? P3. P3 should have 17. Show IP. Show MPLS forwarding table for 11.11. You see, it is 17. Okay, so we can see that this is the bottom of a stack 1. This is the upper layer. Using this only, the packet gets switched to the transport layer. This is the service layer, the VPN label. Dual stack, MPLS dual stack. See, pseudo wire. We were using pseudo wire. Yes. Okay. I hope you understood layer 2 MPLS VPN point to point using pseudo wire. What next is VPLS multi-point.